Hello, everyone, and welcome to this evening's session on NLP from text to production. We have a couple of questions for you prepared as part of this event. I would be really curious to see, what you think, or where is your expertise in terms of the topics that we're going to cover today, as well as what your position on ChatGPT is, because people everyone is talking about it. So until we get a few results, I will start by introducing myself and introducing this session. So for the people that have already joined the previous session, Tony's session, I hope you had a great time. Tony had a really nice content, and I hope you'll also enjoy this other session. For the ones only attending this session, welcome to the session as part of the Let's Talk About IT, the second version of it. So in this evening, I would like to talk about NLP, and especially in the context of deploying NLP models to production. On one hand, because text is the type of data that we deal with both as business people, as engineers, as technical people. And on the other hand is because if we want to infuse this knowledge that or this value that natural language processing models bring to us, and if we want to deliver it to production and bring this to fruition, we will need to be very diligent about it. And I'm going to briefly cover these topics. I will only scratch the surface in the half an hour, but at the same time, I would like to really launch some hooks to you if you want to get started in this area. So I think we can close the poll now. And definitely, I can see a distribution of expertise in terms of machine learning, which is nice. And also it's nice to see that we have a few people from the audience who actually deployed machine learning models. This is also nice to see. I expect challenging questions from you guys as well. And then in terms of ChatGPT, again, a very nice distribution. And I'm happy to see that people are also thinking about the side effects and about the repercussions that these models can have. Yeah, super. So let's get started. So I'm Vlad, and I'm honored to have you as part of this event. A few words about myself. I am a tech lead on machine learning at Yonder. I've been with Yonder for almost a year and a half now. And, I'm a true admirer of true intelligence and wisdom, be it natural or artificial. I think in terms of artificial, we managed to get to intelligence, but I'm not sure about wisdom. So I think this is another barrier to pass in terms of research. And outside, work and the professional stuff, and outside artificial intelligence, I'm a nature and birds lover, and I will also not cover the other dark part of myself around perfectionism. So I won't insist on that one. But since we started with ChatGPT, we've seen lots of scenarios where ChatGPT was used. I think many people already played with it. And as we've seen in the poll, We had quite a few people interact with ChatGPT, and it's definitely useful for many scenarios of like text generation or factual checking with some question marks over there. Sometimes it manages to return good results. Sometimes it doesn't. What I've noticed was that it really manages to give really good advice, and it was super reasonable and it made sense to me. So that's one scenario where I found it really useful. However, when it doesn't, and for example, we have this experiment that Andrew Ng, a luminary of artificial intelligence, when he did this experiment, basically he demonstrated that ChatGPT managed to mention that an abacus is much faster than a GPU, which is definitely a hallucination. And the term, the hallucination, is actually also the actual term used in research to refer to moments when artificial intelligence models actually produce really bad results. So, okay, we've talked about ChatGPT, and many people are seeing it as, you know, silver bullet, right? We as humankind have the tendency to, whenever we see something revolutionary, to try to apply it everywhere, right? But the question is, when it comes to data, and especially textual data, which is private, so it's not published, and for example, ChatGPT did not have access to it, you know, how, as a business, would we be able to get insights of this data? And the answer is no, we wouldn't be able to use ChatGPT for us for these scenarios. And ChatGPT itself admits that in these kind of scenarios, there are more specific models that can be used, and it also introduces the names of tasks that belong to natural language processing. And this is a very good starting point for this presentation. So let's see a few things about how NLP evolved over time. And this is definitely a historical view of how everything started, and how in the memorandum, Weaver just proposed an alternative view of seeing text, other than just tokens, like word-by-word tokens. And it constantly evolved over time, introducing the grammar theories, introducing then the ontologies, and then later on the more advanced symbolic models, where parts of text were represented as symbols. And then later on top of this, we started to see the infusion of all these with the mathematics and statistics in areas. And this gave birth to more like statistical models. But then how did this contribute to the overall landscape of NLP? Well, later on, starting the 2000s, the neural language models concept started to really kick in. And then we also got to abstract a way in which we can use all this knowledge to solve concrete problems. And this is how multitask learning started to gain shape. And by multitask, I'm referring to these specific tasks, like, you know, question answering, or identifying parts of speech, or identifying, names, or simply classifying texts. And then, with 2013, everything onwards, everything rolled like a snowball, because there were innovations on top of innovations, and then lastly, or not necessarily lastly, but in 2015, the attention mechanism appeared, and actually this kind of changed the way in which NLP was done so far. The attention mechanism was actually, or is actually, as we will see, even right now, the most used type of machine learning model applied for natural language processing. All right, so entering more in depth on what we've discussed right now, or more concretely on some of the examples, I would like to show you, I don't know, 3 types of technologies, I would say, or 3 types of models that have been most successfully used whenever dealing with NLP tasks. The first one, and the simplest one, was to simply convert, text into very simple embeddings. Like in this case, we have this specific text, and what we are doing is we are creating a bag of words, basically, which results in an array where for each position, the position represents the word in the text, and then the value represents the count of that word appearing in that text. And basically, this is a way to convert text into numerical format, which will be later very simple to feed into any machine learning model and try to get insights out of this this data. So basically, of course, with some post-processing additions here, they would need to be normalized, and they would need to be split into training data, into test data, but we won't have time to cover all these aspects right now. I just want to get very briefly on the approaches. So if we were to do NLP based on this method, the problem with it is that it's super limited. And as we can see, if we have words outside of the training and validation set in real life afterwards, after training the model, then this would be really hard, because and we would lose this information because we have fixed length arrays. Also, the knowledge that these arrays, or this representation encapsulates, is rather static, so it only represents very limited data, so there's no relation between the words that appear here. However, it's a super versatile implementation, and it can be applied to many models, or it can be, experimented with both deep learning models, or neural network based models, or non-neural network based models, and comparison can be done in terms of results. The next method that I would like us to have a look at is the recurrent neural network, or the newer long short-term memory. Basically, we can see these as unfolded, or as neural networks that can contain some state, some temporal state in them. This is the reason why they're called recurrent, is because whenever we are unfolding, let's say if we were to kind of unfold a neuron, a recurrent neuron, then we would result in multiple simple neurons linked to each other. And as we can see, we have the temporal dimension, which means that these kind of networks, these kind of neural networks are able to actually keep the temporal state. And that's why, since the text is actually a sequence, that's why it's super important, or it gives us additional insight to have the words shown to these networks, and then additional, insights from the text would be encapsulated or embedded or learned by these networks. The only problem is that it's not necessarily suitable for long sequences, and actually it's still hard to use this into more complex, textual content. But the good thing is that as I mentioned, in 2015, the attention mechanism appeared, and basically the Google Brain team managed to propose this new way of seeing models that are able to process text. And the big revolution that the attention mechanism brings is the fact that it actually encodes relationships between the words that it gets in input. And we can see that we can actually make an analogy and mention that the attention mechanism can be seen as a sort of a miniature version of a database, because it also has the key value and query concept. And then this type of machine learning based model for NLP, it actually scales well to relatively large input text. And actually it's later used in state-of-the-art applications, and it's deployed successfully in production. It provides in many areas and many scenarios quite good results. All right, now that we have seen a few, let's say, a glimpse of the, let's say, technical details of NLP, what's the next step? Okay, we have attention mechanism, but since it's quite complex also to grasp, what can we do with it? And the answer lies into transfer learning. Basically, in the last few years, we've seen lots and lots of models being developed by research teams, and actually they are also published so that the larger public can, take them, apply their own data on them, and then deploy them as fine-tuned model. And this is the power of transfer learning. It's the fact that we can now see the models together with their previous training, super expensive training, as a sort of a library in software engineering, in classical software engineering, right? We take the model that we need, we know that it had been trained on a set of data, and then based on our own representation of the data that we need, then we can fine-tune them or retrain them on top of what they were already trained, and obtain a new model which has the semantics of the data that we're interested in getting insights from. And I will also introduce, with transfer learning, one of the most successful projects, which is which aims at democratizing machine learning and state-of-the-art in machine learning. So I suppose many of you have already heard about the Hugging Face hub and about Hugging Face in general. Basically, when we're talking about NLP, these are the examples of tasks where you can go to the Hugging Face hub, choose the model that you want to take and potentially fine-tune, and then deploy your model. So it's quite simple. You can see lots and lots of models over there. And it's really a great thing to start learning NLP from. And speaking of which, I can show you, and I will, for this, I would like to go back to my previous slide, since I introduced to this slide, and I can show you a very quick demo of the Hugging Face Hub, where, I mentioned that the text over here is, we can turn it into data fed to machine learning models by using simple embeddings. But what if we want to track down dependencies between various words? So for that, I'm going to open the Hugging Face Hub. And I want to show you over here. So I'm just going to increase the font. I'm going to go to huggingface.co/models. And here on the left-hand side, we see all the types of tasks that they can be used for. And here, I'll go to question answering. And you can see all the models that have been used over here and the amount of times they've been downloaded. And let's take the most popular one. And let's actually put the text over here as a context and actually ask this model what animal is already gone when the dog gets on its feet. So now we get it to compute it. Of course, you can, as you can see, it's super fast. It's super simple to really try the model that you would like to use. And of course, in this case, you would use the vanilla model. So basically, it's only the pre-trained model. But remember that if you have very specific business data, you can take this model, fine-tune it, and then deploy it with the additional parameterization given by your data. So as you can see, since we're using a transformer model, so basically is the transformer architecture that I was mentioning in the slides based on the attention mechanism. And it keeps kind of the relationships between the words in the text. We can see that it successfully manages to find the fox, even though here we don't specifically mention the fox. It's just it over here. All right, this was my brief demo. I'll just jump back into the presentation. All right, and we will go back to, okay. So we've seen it all. It's super nice, super quick to really experiment with them, but there is a but over here. What about deploying all this to production? What does it take to really take one of these models, do all the things that I've mentioned with them, and actually, be diligent about creating a production grade software relying on these models? Well, actually, the code itself in a system like this is just in the middle. It's just this part, in an abstract manner, we can consider just this small part of the project. But in order to get to actually code and fine-tune, for example, a model that you take from the hub, you will need to do a lot of activities. So for example, you'll need to get the data that you want to fine-tune your model on. You need to extract the features out of that data. You need to verify that the data conforms to what you're expecting from it. You need to label that data. So basically, you need to provide the ground truth based on which you can tell the model that, okay, these are the answers I want you to give me. So basically, these are the things, the labels are the things in supervised learning, the things that help the model actually learn what we want from the data. Of course, we also need the data governance in a more complex system. And then on top of that, of course, once we have the model that we will be training or fine-tuning, we need to evaluate it. We want to see whether it's good enough. We want to iterate over it. We want to analyze all these results. And also, we also need some process management tools to also encapsulate all these complexities so far. And on top of that, we need to configure, again, the orchestration of all these tools. And then we also need serving infrastructure based on which the model would run and offer API responses. But that's not all, because on top of those API responses, we will also need to have some monitoring and observability, because otherwise things will get easily unmanageable. So it's definitely a lot of things to get hold of. But the good thing is that we have a way to really manage all these things, because there's this concept of ML ops, which in a similar sense as DevOps in software engineering, it actually brings a set of practices and tools that allows teams to be diligent about the entire process end to end. And as you can see, it revolves around the design, the model development, and the operations that are required in the aftermath of actually deploying the model. Because as we have seen, and as some of the later surveys surfaced, most of the models that are trained don't actually make it to production. It's actually only roughly 10% of the models that are being trained that actually make it to production and are sustainable, so actually produce tangible values to businesses. And the main reason is that there's no or little diligence in the entire process of deploying it and maintaining what we have deployed over there. And I'm going to show you another diagram taken from a very interesting and insightful article, which I totally recommend you. It's on Martin Fowler's website, where it actually emphasizes very nicely the artifacts that result as part of a machine learning pipeline. As we can see, besides the application code that we would have in classical software engineering, we also have code for all these other, like the machine learning, actual machine learning training code, and then of course the testing code, again, as in software engineering. But then we have these two other types of artifacts that we need to track down to version, which are the model and the data, of course. But the good thing is that once we have these mechanisms and these processes, and we gradually automate them, all these steps as we go along with the pipelines and with the releases of new models in production, then we as teams are able to better scale and better maintain our models, so that we continuously improve their performance while bringing the value. Okay, I'm just going to enumerate a few of the enablers through which we can do all these. Of course, we've all heard about the popular ML frameworks such as PyTorch or TensorFlow or scikit-learn. And then on top of that, the dedicated platforms and ecosystems that are aimed at making it easy for us to get this state-of-the-art in research. And I will also mention the cloud platform services that have lots of super useful tools and integrated tools that make it much, much easier to cover a project, a machine learning project end-to-end, from infrastructure required to do so to various stages in the pipeline that can be done using the services that they provide. And last but not least, there are also open tools that can be used for end-to-end conception of these machine learning MLOps pipelines, such as MLflow or ZenML or Metaflow. All right, now that we've reached this part of the presentation, I think it may be a little overwhelming, but then since I mentioned to you that ChatGPT is very good in offering life advice, I asked it, you know, where can we start? Because this world is, you know, ever expanding. And I think ChatGPT manages to offer very good advice in terms of, you know, where to start from when you want to start learning about NLP, and how to deal with this ever-changing nature of state-of-the-art in NLP. All right, I'll leave you with ChatGPT's advice on where to get started. Hope you liked this session. Thanks a lot. All right, so now that we're done, we have a few minutes of questions and answers. I'll just stop sharing my screen and I will sorry. And I will open up for questions, but just one tiny. For some reason, I can't see Zoom clients. Apologies for that. I have some technical difficulties with Zoom for some reason, in which I cannot see the questions. All right. Finally. All right, cool. Now I can see the questions. I don't see. I don't see any questions from the audience. All right, actually, yes, we have a question. We have a couple of questions. All right, super. So we have two questions. First question from Dan Alexandru, who's asking, in practice, what are the NLP models used for in production? Actually, as we've seen also in the Hugging Face hub that I showed, there are lots of NLP models, and it also depends on the task that you would like to work on. Let me just show you for a few examples. So here, if we're going to models, it depends again on the type of task that you would like to accomplish, right? As I mentioned to you, even the simplest approach of, you know, text classification, people use transformer-based models. or they can use LSTMs as I presented. But if we want a model that is able to perform multiple tasks, and this is the meaning of multitask learning, then I think the transformers are most successfully used, the most successfully used models for these types of tasks. And for example, we have, this is the most popular, the BERT or Roberta, as we can see here, or the GPT-2, which is the precursor of GPT-3 that we know of, or that you may have heard of. So basically, these are all attention-based models, most. And actually, most of the things that we see here, they're also mostly attention-based models. Of course, if we filter by name, let's go to the, let's say, text classification ones, and we filter by LSTM. Yes, we have also bidirectional LSTM, or, there are also ways to have multiple types of technologies within one model. So basically, I would say, there are lots that can be used and which are successfully used in production. I think the more important part of it is the data that we get to show them when training or fine-tuning them. And maybe this is a topic for another webinar, the way in which we train models. All right. Thanks for the question. Really good insightful. All right. Is there a different approach for NLP in chatbots versus voice bots? Thanks for the question. This is an anonymous question. So basically, the way in which things work is that we can see the voice bots as being somehow chatbots, but on steroids, in the sense that they need to perform another machine learning task, which is voice recognition. And speaking of voice recognition, since the voice is actually a sinusoidal, or it's a sequence, voice recognition was also done until not long ago, and even currently there are some models which rely on LSTMs, to recognize the voice and transform it into text. And once this is transformed into text, then everything goes the same way, I would say. So basically, just in a nutshell, voice bots are just chatbots that need to also perform the task of voice recognition. All right, then we have Razvan. Are there any well-known certification programs that can be completed? Maybe something from a known authority. This is a good question, Razvan, and I also thought a bit about this topic. There are a few certifications. Of course, when we're talking about technical certification, I think one of the authority that comes to mind, or the most important that comes to mind, is of course Coursera. But then I also mentioned about Andrew Ng. So Andrew Ng, being one of the most successful professors and academians in artificial intelligence, he has formed also the deeplearning.ai organization, and they also offer some courses and certifications. And basically, they're also published on the Coursera platform, by the way. On top of that, of course, we have some specialization certifications from each cloud provider. But in this case, the cloud providers are also insisting on their specific tools and platforms when offering the certificate, or during the certification program, and the outcome of it, of course. Next question comes from Vlad. From my point of view, which is the minimum time for a model to get from dev to production at the first release? Also, can I give an example of required skills for a team to do that successfully? Oh, wow. This is a very good question. And I think it offers holistic insight on what it takes to really deploy a model to production. I think it depends, but since we were talking about transfer learning, let's take this situation when we want to reuse something which is already there, because I think Vlad's question goes towards, okay, how fast can I, how fast, yeah, and actually, yeah, now that I read it again, which is the minimum time for a model to get to production. First of all, we're using transfer learning. And when we're using transfer learning, we don't really need to recreate the model architecture. So we take it as is based on, the task that we want to complete. And the majority of time that we need to spend is to get the data that we want to train the model on and to label the data. So for example, if we want to classify or to identify tokens from a certain document, let's say from PDF documents, then we need to take the PDF documents that we want to train the model on, and then we need to find the software, find a component that helps us label them. There are by the way, lots of offerings also in terms of data annotation or labeling, so that we obtain the ground truth that will help us to train the models. So I would say this is most of the time that needs to be used to really identify the data and the distribution of the data that you want the model to learn from, and then to evaluate this model. I think these are the two things that take most of the time. And of course, depending on the complexity of the task and the complexity of the data, it can take anywhere from, let's say, sunshine scenario, a week, since we already have the model, because, a week for a person, and all the way to, a few months for a team, of course. But again, this depends on the expertise and on the amount of people working on it, and also on the complexity of it. And then in terms of examples of required skills for a team to do that successfully, I think first of all, we need a bit of data acumen. So we need to understand a bit the statistical sides of the data, the statistical side of the data. We need to understand how we can ensure that the model that we would produce doesn't really get biased information, because otherwise we'd get biased information in production, which is not good. So yes, data analysis task is a good task to have if we wanted to really deploy something to production. Then the next one would be software engineering skills. Of course, whenever we want to really diligently develop something and integrate it into existing software, especially in production, we need to really think about the stages that we need to accomplish. And of course, since we're talking about deployment, we also need a bit of infrastructure related skills, especially if we want to automate the infrastructure. So for example, nowadays, AWS also offers a very easy way to deploy infrastructure as an engineer via CDK. So basically by writing Python code. Okay, we're quickly running out of time, but we have 2 more questions. Hopefully I'll manage to answer them. Tony is asking what I think. Do I think that a production model can be influenced by the user's inputs to go in a wrong direction with its responses, maybe how can I control that? Oh, wow. Yeah, this is a super good question. And this is also not an easy problem to solve, because there was many research carried on one hand, tricking machine learning models, and on the other hand, identifying these kind of cases where models could really screw up answers. So for example, there was an insightful article in which the authors tried to fool traffic sign recognition engines, and just by infusing noise into the image, basically by infusing a little noise such as a rain, but it was an artificial noise, into an image of a stop sign, they managed to fool the identification system to think it wasn't a stop sign, but instead go forward sign. So this is really a topic for debate as we speak. And I think it really depends on the area of machine learning where the models are developed to also produce models which are resilient to these kind of attacks. But of course, models are not invulnerable. So yes, there's this thing that needs to be taken into consideration. All right. Last but not least, another question from Vlad. What is my opinion on using NLP for translations, and how accurate can the translations be? I think that NLP, and especially the transformers, are successfully being used for translations. And I think since the transformers, so the attention-based mechanisms, have appeared, we've seen lots of cases where actually the way in which models managed to translate text was even better than the way in which some linguists translated that. So I think we're reaching parity with human translation also in NLP. All right, with this, I would like to thank you again for your attention, and also for the interaction and for the interesting questions, and hope to see you soon at the next webinar. Don't forget about the next webinars, and if you don't know what to attend, make sure you get to the Yonder's page, and you will see all the listed upcoming webinars as part of Let's Talk About IT. Thank you.